Hi, I'm Angie Kellen, and this is Shot Talk with Aki Fujimura. Aki is the CEO of D2S, and D2S is the managing company sponsor of the eBeam initiative. Hello, Aki. Thanks for joining me today.
Hi, Angie.
Let's start off right away with the takeaways that you might have from the recent SPIE Advanced Lithography Conference that was held in San Jose.
Yeah, so great event, as always. This year, I think it was kind of the coming out party maybe for EUV and multi-beam, EUV lithography for wafer projection and multi-beam writing for masks have both been going on for about 10 years now. I guess EUV a little bit longer. I got the distinct impression this time that everybody believes that both things are real and here. With EUV, there's a little bit more, maybe a trend away from, is it going to happen? Yes, it's going to happen. But how do you make it as effective as possible? That's probably more the topic of discussion this time. Multi-beam-based mask writing is required for EUV lithography because the EUV masks have to be more precise. So it's just in time that both IMS and NuFlare did great presentations with great results on both of them. So multi-beam is ready in time for EUV production, so that's really great. I thought though that even though for lithography conference that's the exciting thing. What I noticed that was really interesting was even though it's an advanced lithography conference, the conference was dominated by topics about computing. Quantum computing was the topic of the first keynote speech. That's how the conference started. Very, very exciting technology. It's going to take a while though. Neuromorphic computing, there was a session on that. That's also, it's more shorter term than quantum, probably longer term than deep learning, but it's around the corner and that's also interesting. And then machine learning, there were 4 entire sessions on machine learning, and there were 9 papers in addition to that outside of those 4 sessions. So total of I think 28 papers out of 290 total papers. So really machine learning, a computing topic, had more papers at the Advanced Lithography Conference than all the alternative lithographies combined together, DSA or nanoimprint or eBeam direct write, and more than that, more than those topics combined together. So yeah, clearly computing is in the minds of everybody, both in terms of using it for enhancing our machines or processes or whatever, but also as a driver for new requirements for what we need to build in our community. So, very exciting, and especially from, my perspective as CEO of D2S, and all about GPU computing, GPU acceleration. So, all these, new ways to think about how to leverage computing in the future, that's really exciting for me.
That's fantastic. And adding to that excitement for SPIE, the eBeam initiative held its annual luncheon. And of course, congratulations that ASML has joined the eBeam initiative. Yeah. Tell us more about that.
Yeah, it's a great honor to have ASML join us. Everybody knows ASML as the ones that's not only dominant in 193i immersion lithography, but practically the only player in EUV lithography. But in addition to what they do on the wafer projection for lithography side, they have a significant presence in eBeam based machinery for semiconductor manufacturing with their past acquisition of Hermes Microvision, and also a very recent acquisition of the Mapper direct write technology. So they're very prominent in the eBeam world in addition to everything else that they do. So Indeed, a great honor. A speaker from ASML was at the eBeam Initiative event, actually. We usually have 2 or 3 speakers speak at the event, and this time we had Harry Levinson of HJL Lithography speak about computing EUV, EUV masks, and there are enhanced or increased need for computing resources in order to do EUV lithography or EUV IoT OPC. So Harry talked about that. It was interesting. And then Liu Pang of D2S talked about enabling deep learning for various different uses. And then Yu Cao talked about using deep learning in a new capability that they call Neuron, N-E-W-R-O-N, to accelerate and to enhance the accuracy of their IoT OPC engine. So overall, incredibly interesting, varied topics. What I thought was particularly notable, though, is even though the topics of the 3 talks were very different, all 3 talked about curvilinear masks. And curvilinear masks actually came up a lot during the conference in general also. And it makes sense in ways because multi-beam is real and here to stay, and multi-beam based writing is an advance over VSP writing in one other way than just write time for precise masks, and that's curvilinear masks, and being able to write curvilinear patterns, not just rectangular or rectilinear, but curvilinear shapes can be written on the mask, and obviously there are wafer benefits of doing that. So that was great. Kind of an interesting trend in what's going to happen in the coming years.
Well, it sounds fascinating. Now, last time that we talked about the new Center for Deep Learning in Electronics Manufacturing, the CDLe. Now, do you have any projects that you can report on or any results that you're willing to share?
Yeah, so we're still in the process. We just started in September. CDLe is a partnership of New Flare, Micronic, and D2S. So all 3 companies are together working in San Jose to produce deep learning results, and great progress. But one thing that had been talked about was actually Leo's talk at the eBeam Initiative event, where he talked about enabling deep learning in its D2S's customers. And so whether your semiconductor equipment manufacturer or your fab or mask shop or whomever you might be, if you're thinking about deep learning, then there is help that can be gotten in how to get started on deep learning faster. So not just using deep learning on products that you build, but deep learning in services you provide, or deep learning as a way to enhance the methodology that you have or accelerate something like Yu Cao talked about at the ASML Brian. There are many ways in which deep learning can be used. So enabling that in your own company is what Leo talked about. So that's actually work that's being done at the Center of Deep Learning. And in addition to doing the work there, Center of Deep Learning itself is kind of a guinea pig, like an alpha site for this capability. So that's one thing that's happening that we talked about. There are other things that you hear about in the rest of 2019.
More to come.
Yeah.
Now, in the past, you and I have talked about the adoption of EUV and multi-beam technologies. Let's talk about inverse lithography technology, or ILT. Is this coming of age? Is there anything that you can see that might be holding back its adoption?
Yeah, ILT is really required today for the particularly difficult parts of the 193i based masks. So people use it for hotspots. So really places where there isn't enough process window otherwise, they want to plug in a solution from IoT in a hotspot-based methodology. But I don't know of anyone that's able to use it at the full chip level, and what's holding it back is that the runtime for IoT is too long, and complex or very sophisticated leading edge OPC takes long enough. It's compute intensive enough because it all has to be lithography simulation based, and you have to iterate on that. It's just like, that you have so much computing to do. It just takes time to do that, and IoT is even more than a sophisticated leading edge OPC. So yeah, it's the compute time. That's the barrier, and I think there will be some breakthroughs coming through, but we'll see. We'll see what happens.
Great. Well, thank you. That's all I have, actually. So I want to thank you so much for sharing your insights with us, and good luck on everything that you have going on as well, too.
Yeah. Thank you.
As a reminder, for the luncheon presentations, as Aki had mentioned earlier, please go to the ebeam.org and you can get a copy of the papers. I want to thank you for joining us as well, and hope to see you next time for the Fine Line Video Journal.